Hey guys, my name is Taylor West, and this is the Immunology Test 3 video. And today I'm just going to be talking about class switch and positive and negative selection. So first up, I'm going to talk about class switch. Class switch only affects the heavy chain because only the heavy chain, excuse me, because only the heavy chain is what determines the antibody class. So class switch is just changing as a process which switch from the expression of IgM to another expression of a different Ig. So it could be IgA, IgD, IgE. This switch happens in the switch S region upstream from the CH region. So um, in order for this to happen, there must they must receive a signal from a CD40 or B cell toll-like receptors in order to engage in class switch. So these cytokine signals received by the B cells determine which class of Ig will make. So this is where your second cut occurs. So the second cut right here determines what type of antibody it's going to be. So what isotype it's going to be. So if you had a lot of TGF beta present, you would cut right here and that would form IgA. So it would change from IgM to IgA. So your first cut starts right before the mu and delta, so IgM right before here, and then you cut based on what cytokines are present. So you can get IgG, IgE, or IgA. And like I said before, this only affects the heavy chain because that's what determines what type of isotope antibody will be present. Um, class switch is a class switch recombination cannot occur without this transcriptional activity. The cytokines must signal the B cells to induce transcription from the germline promoters located upstream from the prospective donor and accepted switch region. So none of this can happen if the cytokines don't signal where to cut and promote all this reconstructing to happen. Um, class switch is also initiated by AID. Um, class switch can occur more than once during the lifetime of a cell. That means that you can go from IgM to IgA the first time and then recut again and become something else. So this can happen more than one time in a cell's life. Okay, so now we're going to go on to positive and negative selection. So this has to do with the T cell development. So this is positive and negative selection for thymocytes. So T cells are born in the bone marrow, that's where they're created, and they move through the blood to the thymic cortex, which is the outer region of the thymus gland. These are where they become educated. So at first they're just hematopoietic stem cells in the bone marrow. This means they can become any kind of blood cell. So white blood cells or red blood cells. So when they start moving from the bone marrow through the blood, they become precursor cells, or formerly known as pre-T cells or pre-thymocytes. This process occurs, this is like the early development of T cells, so before they are recognized as CD4 or CD8. This can happen in the thymic cortex and the thymic medulla. This whole process deals with double negative to double positive to single positive. So first off, we're going to look at um, our cortex. So in the cortex is where we're going to have positive selection. So positive selection is basically just the survival of T cells that have TCR receptors that are capable of recognizing self-MHC molecules. So this all happens in the cortex. So this requires a positive interaction between the T cell and some receptor, which, like I said before, allows it to survive. Um, excuse me. So just by selecting for those cells that are producing a T cell receptor that can recognize and interact with cell MHC. So in this one, you start off with a double positive thymocyte. This double positive thymocyte has three directions it can take. If you have a high affinity interaction, which means it overreacts to the MHCs on the MHC on the cells, then it can lead to negative selection, which is the death of that thymocyte. So if it has over affinity, so high affinity interaction, meaning it overreacts to the MHC, which is something we don't want, it will have negative selection and die. Now, if it has no interaction, which is 90 to 96% of the thymocytes, there will be death not by neglect, which means apoptosis. So if there's no interaction, so if it cannot recognize self and there's no interaction with it, it will just die off. So about 2 to 5% has low affinity interaction. This is kind of like the sweet spot. This is right where you want to be. Um, Sorry, it said I didn't have any sound, so I was just checking to make sure. That's what I was saying. So when you have 2 to 5% low affinity interaction, like I said, this is like the sweet spot. This is where you want to be. So it recognizes itself, but it doesn't overreact, but it still has some kind of positive interaction. So now you are moving on to positive selection. This is where your thymocyte either becomes CD4 or CD8, which is our T helper cells and our T cytotoxic T cells. So that is based off which MHC they reacted with. So if they reacted with an MHC class 1 or MHC class 2. So then now they are moving down into the medulla. So now we move on to the medulla. This is where our negative selection occurs. So negative selection eliminates T cells that react too strongly with self-MHC. So this is the ones that are overreacting entirely too much. So they recognize it, but they overreact to it. So we have a negative selection. So the first part of the cortex, we're just trying to see if it will even react to it. If it reacts too much, doesn't react at all, or reacts perfectly. The medulla, we are trying to make sure it doesn't overreact to self-antigens at all. So here it interacts with more membrane thymic epithelial cells, and these will have AIR. AIR is an enzyme that causes random expression of proteins from inside those cells. They express a lot of MHCs and a lot of self-antigens. So this is where we can get a lot of array of things for it to react with to see if we have an overreaction. If they are negatively selected, that means they reacted too strongly with the self-antigens that are being expressed on this AIR protein in the MHCs. So they will just die off. So they apoptosis. If they overreact too much, they will just be killed off. But the mature CD4 and CD8 T thymocytes migrate out of the medulla into the periphery, into the bloodstream. So this is where they move out, and they will move through the bloodstream, and most of them hang out in lymph nodes close to that area. So the medulla is like a double, I see it as a double check system. So the cortex, we saw the ones that didn't overreact, they reacted perfectly. So now we're moving them to the second stage of education. We're seeing if they overreact to too many things. So that's how I think of it, and I hope that helps, and thank you for watching.